Hi, everyone. Thanks for being here. Hi, my name is Alison Snyder. I'm a managing editor here at Axios, and with me on stage, hi, we're going to keep going, is Peter Koerte. Nice to meet you. Thank you so much for doing this. He is Siemens AG's Chief Technology and Chief Strategy Officer and a member of the managing board. So thanks for doing this. We really appreciate it. And I think we're just going to dive right in. And my first question for you is, Siemens has sort of long been associated with transportation, healthcare, energy, and you're trying to make yourself over as an AI company. How are you going about doing that? And how important is that here in Davos this week?
Well, it really matters because if you think about what we need most is a good employment, a good productivity, good growth. And we believe that technology actually can bring that. So the manufacturing sector per se is really suffering from a shortage of labor. And no matter if you look in all the industries from chemicals to automotive, pharma, all the way, we see that the people are missing that really want to work in an attractive industry. And we believe that actually these are the true heroes if we give them the right technology in order to do so. So at Siemens, we've done electrification in the beginning, automation, but now we go on the next leap, which is all about digitalization, and of course digitalization infused by AI, because of all the data that comes from all the machines, from all the buildings, from all the trains that we run.
Jake just said something provocative twice about AI and SaaS companies going extinct if they do not have data. Siemens is data rich, right? You have 300,000 employees working all over the world. What is your challenge though with the data that you have? And yeah, start there.
No, it is fair. We know, in particular in the industrial space, we know that there are 17 billion devices that are actually receiving and sending data. 17 billion is twice as many people on this planet, which means fundamentally we don't have that issue that we are running out of data as training for the large language models. It's not the case in the industry. We have a different challenge, and that is data access, where truly companies have to trust each other to share the data so that you actually can make use out of it. And second is, of course, no hallucination or anything has to have happened. Because if you think about, if your AI gets you the tone of your email wrong, that's one thing. If you think about programming a machine, running a train, running a building, that's an entirely different thing. That's why we say industrial AI needs to be three things. It needs to be safe, it needs to be reliable, but most importantly, it needs to be trustworthy.
So Siemens, working with Microsoft, you've developed something that you call an industrial co-pilot. Can you take us, sorry you guys, I was not speaking to the mic. Okay, Siemens, in partnership with Microsoft, has developed an industrial AI sort of co-pilot. Can you take us to the factory floor, whether it be in, again, transportation, healthcare, somewhere? What does it look like? What is it doing? Who's working with it? And how's it going?
Yeah, if you today are an industrial engineer or somebody who has to actually set up these machines, you speak in a very specific language. And it just so happens that most of these people that are able to speak that language are just leaving the workforce, because we see all the boomers going out and the younger generations coming in. And for them, that language doesn't mean anything. And they have no appetite to take it on. So Python and these kind of environments, where languages where you can program in a state-of-the-art environment, that's what they're looking for. So we said, what if we could make it go away altogether and you just tell the machine of what actually needs to be done. So instead of writing automation code, you just tell the machine, the robot, to pick this glass and then put it over there, and then actually all the code is being generated. So that's for setting up the machines, which is one thing. But the harder part is we just learned, and I came across the statistic which really stayed with me, is that the average tenure of the factory worker level is dropping from 20 years down to 3 years, and that is only since 2019. So by and large, you have a lot of people that have no clue actually what's happening. So imagine you're working on a factory floor, and it's only you, nobody else, and the machine in front of you breaks down. But you're the guy who actually is responsible for making it run. What do you do? And if you don't reach your manager, anybody, your colleagues, then you have a big issue. So we decided that with industrial AI, we can actually democratize that knowledge. We can bring it, we can learn it, we can teach it, and then really tell the worker whenever that is needed, 24/7, even on a Sunday morning graveyard shift, to say, you know what, this machine is broken down because that ball bearing maybe was out of center, and so therefore you have to take the following 1, 2, 3, 4 steps. And that is fantastic, because with that we can capture the knowledge as people exiting the workforce, and we can infuse the knowledge as people are coming on the shop floor.
And what is that in terms of productivity? What do you see productivity-wise, efficiency-wise? What's the payback for you?
So far it's early, as with most of these AI applications. We know that we have about 100 companies that are working with it right now. We see that for sure the time it takes to troubleshoot any kind of failure is much, much faster. The quality of it is faster, but we are still lagging these large-scale studies, obviously, that gives you the productivity increase of whatever % that is.
But at the end of the day, actually recently I think there was a WEF report that found that 41% of businesses said they were going to cut jobs because of AI. So there's a real threat to workers. How do you how do you balance that with the optimization that you're trying to get, and what does it mean for them?
Yeah, the companies that we work with is actually, it's quite the opposite. So the report I know is that until 2030, we're going to miss 85 million people in factory jobs or in worker jobs, so industry jobs, which means that we have a shortage of labor. And it's not so much about the fact that AI is replacing them, because we believe that actually it augments every factory worker. So we give that knowledge to the people that are coming online. And we haven't seen that yet in terms of that threat in particular, where people say, you know what, the AI is going to take my job away.
You don't see it?
I don't believe it, and I don't believe it for the very reason. If you think about, let's say, 20 years ago with robots, it was the same conversation. We talked about robots being on the shop floor and taking all the factory workers away, and then we have a dark factory. Run around the factories I know are definitely different than they used to be 20, 30 years, but there are still people around, except that, of course, the qualification has changed, and that is really now going into the areas where you need problem solving and all the skills we as humans are good at, as opposed to the repetitive tasks, which obviously the robots, and to me AI is nothing else than robot in the digital age, is really doing.
So when you develop something like the industrial co-pilot, are workers at the table? Are they involved in those conversations? What's the input that they give?
It's both. So we co-developed it, of course, with the data in particular from the shop floor, and therefore also we needed to know in which environments they were being created. But then also now, as we roll this out, we continuously refine that. For example, the question of that human-machine interface, so how do you actually consume the data? Where do you consume the data? Is a very important part. So do you go to your smartphone? Do you go to the machine itself? Will we eventually see those classes, right? That actually will tell you, you're looking at the machine, and then, of course, AR, VR, just prompting gives you the advice of what to do. These are the kind of things where it's very fluent, right? So we just launched it half a year ago, but that is all happening as we speak.
What do you need to, I guess, or what's needed for industrial AI to sort of fulfill its promise? What's needed technically in terms of AI advances?
So technically, the most important part, it comes back to, it's the data. It's not the models, it's not the compute power, it really is the data. And for the data, we need to have high quality data. That means the edge cases, so that we have that ability to guarantee for a very reliable system. And that is, of course, after all, something that, there's circumstances you haven't envisioned for to make it really industrial grade and hard. We have those operations. For example, we have streetcars. So streetcars that actually drive autonomously, and they're AI powered. So we really took it all the way to the end, but it takes longer usually in industry than it takes in the B2C space.
Are you seeing a flywheel yet between that data and the AI that you're developing? Are you starting to actually see it?
In certain domains, so wherever you have, for example, on the automation side, with automation code, this is where it starts. The next one that we see is on design data, which is fascinating, because if you think about designers, so engineers sitting in front of a CAD tool, you usually start with a blank sheet of paper. But what if you actually, A, take the libraries, but B, if you tell the system actually how can we further optimize it by reducing weight, reducing stiffness, whatever that is. And so actually the AI in behind does it, and we see these communities, now they're coming together, they're getting increasingly excited. And we see that, yes, but early stage.
I was like, don't drink that. So I want to switch gears for a second. There's geopolitical tensions around the development of AI are ratcheting up, right? There's tariffs, export controls, political personal relationships, talent flows. What impact do you see that having on your development of your AI and sort of deployment of it in the next 4 years?
All right. Well, we are lucky if we can predict it for the next year, because regulation is rampant, and we of course know that. By the way, regulation is happening everywhere in Europe, in America, in China. So we always say regulate as little as needed when it comes down to the industrial space, for the very reason that our customers are completely self-sufficient in a way that they are grown up and they can make their decisions, and we have contracts in between that govern, of course, the services we provide to our customers. So therefore, it's a different conversation than you have the conversation with consumers, which obviously is a different way. We, of course, follow all the regulations that are out there, but truth be told, it becomes more complex because you need to have a lot of people that understand the regulations, what it means if you want to make that product available in geography A, B, or C. And second, of course, sometimes that means that you have to retrain the model on local foundational models or even redeploy it on local clouds, which means, again, it drives up cost and therefore it drives down the scalability of the product. So generally speaking, the less, the better. But we, of course, understand that everybody wants to make sure that AI is safe and reliable, as I said earlier.
So do you think it'll affect the pace of it?
It depends on where regulators are going. Right now, we clearly can see in Europe it is slowing down. In the United States, we shall see today and in the next 4 years to come, obviously. And then, of course, there's China, where, of course, in China, AI is really adopted at a rapid pace because they understood that AI can be the next frontier for leveraging productivity much, much faster than anybody else. And if you have a very large, of course, home market, like in China, like the United States, of course, that is something that you have to leverage.
I met with someone this morning who was telling me that they walked through a factory in China recently, and it was a half a kilometer walk, and they didn't see a single person. There was no employees, all automated. I mean, is that the goal?
It is hard to say whether there is no person at all. It really depends on what you're manufacturing. So, for example, in the battery space, battery manufacturing space, which becomes extraordinarily highly automated, but then there's a lot of jobs after all that are required in order to do that, like packaging, like food and beverage, where this will stay quite a while.
We're out of time, but I do have, as Nick said, we'd like to end on one fun thing. This is not your first Davos, correct?
It is my first Davos.
It is your first
Davos? It is great
Davos?
being with you,
yes. Oh my gosh, I just assumed. Okay. What are you looking for? Oh man, okay. So what do you, how did you?
Okay, no,
yeah, I know. It's a warmer Davos. What are you doing what's one thing you're looking forward to doing that doesn't involve all these people and just sort of being here in the Alps?
Actually, I'm going to take a lot of great pictures and I'm going to send them around. And of course, feeling bad about it not being on the snow-topped mountains and not being down here.
Thank you so much for being here. I hope you enjoy your week then. Jeez.
Thank you, Alison. Thank you, everyone.
Thank you, everyone.
Thank you.
Please stick around. There's going to be another event this afternoon. So if you want to take a break and come back, we'll be here. Thank you.